What up, fam? Long time no see. Haven't been making videos lately, but we're back at it with this test number 5 Polygon Similarity review. Apologize to those of you who I was late for, but let's just hop right into it. So here, write the name of each polygon. So basically what you want to do is you want to make sure you have all of those sides. You can just count them up. You don't necessarily need to actually number them off like this. I just don't like counting incorrectly, and that's the way to make sure I don't. So it's a 5-sided figure. So the correct name for a 5-sided figure is a pentagon. However, the word pentagon is optional. That is a 5-sided figure that we kind of talked about before. But really, instead, we can call it a 5-gon if we wanted to make our lives easier. I do recommend actually learning those fancier words. We took notes on them, but the main reason to learn those words is because, like, the word penta always means 5. It means it in your video games. It means it when it comes to figures, and it will mean it anytime you see that word penta in the future. It's used in chemistry. It's used in physics. Whatever, it shows up all the time. So that root word shows up. And just like this one, the word octagon shows up, just like in the word octopus. And what do you know? Octagon means 8 sides, and we can also call it 8-gon. Either one of those would get you full credit. I have a new setup. Yeah, obviously you see it's a new room. I gotta get used to looking over this direction instead of like always looking this way. I don't know. Whatever. I'm gonna stop talking to myself. Keep doing the problems. We got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. We call this guy a hexagon. The other correct names for this one is going to be a sexagon and a sixagon. So some of these have more than one name. That one's got 3. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We call this one a decagon. Decagon, I can spell. And we can also call it a 10-gon, but also get you full credit. Let's move on to the actual math problems. Here we go. So continuing on with these actual math questions, find the interior angle for a sum. So I did correct this on the actual test, but this is a typo. It should clearly be a multiplication. You're not dividing the number of sides minus 2 times 180 or divided by 180. You are multiplying those two things. So there are 2 ways to go about this problem. I'm going to do question number 5 using the formula. Then I'm going to use number 6, kind of where the formula comes from. And honestly, it's kind of a way that's even easier to deal with. I wonder also why it's kind of, oh yeah, it's because the paper's not flat. There you go. All right, now it's better. All right, anyway, so we have that 5. We're gonna go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there are 10 sides to this figure. So that is what n is. So this last number is n. S is going to be that sum. So the sum that we are looking for in this problem is going to be that parentheses 10 minus 2 times 180. I don't know why I moved it up there like I was writing a fraction. That'll happen in number 7 and 8. You throw that into your calculator and you'll figure out that the sum is in fact going to be 1,440. You just multiply them, put them into your calculator exactly as it appears, and everything will work out just fine. So we end up with 1440 degrees for this one. However, you could have also done this question another way, where you connect the top part of this down to here. You connect that bottom part of it down to here, and then you have a 1, 2, 3. What do we got? We got 3 triangles. The idea is I connected one vertice to another vertice that it wasn't adjacent to. So I didn't bother connecting it to this one because it's already kind of a straight line there. We just have these 3 different ones. And guess what? Well, we have 3 triangles. So we have 3 times 180, and that's going to give us 540 degrees. This is simply one way of doing it if you want to, but it's actually the same idea because you have 1, 2, 3, 4, 5 sides. 5 minus 2 is 3 times 180. There you have it. Anyways, I'm moving on with my life. Here we go. This one, same exact idea. I'm going to do it once with the number of sides, once with the triangles. I'm going to start off with the triangles this time. So we got to go straight down here, straight across here, straight over here. We got 1, 2, 3, 4. And then we have 4 multiplied by 180 here. And if you multiply that out, you get 720. However, the question is not asking for the sum of all of them. It is instead find the measure of one interior angle. So because you're trying to find one interior angle, and these are a regular polygon, remember the word regular means all those angles are the same. You take this total and divide by the number of sides. So you actually end up needing to write down that there are 6 sides anyways, because you end up doing 720 there divided by 6 to get that 120 degrees final answer. But maybe this is one where the formula is kind of preferred, because if I just did the formula straight up 1, 2, 3, 4, 5, 6, 7, 8, then I could just use that formula initially. And this is where I was thinking about that fraction. We'll write it up above. I could just do 8 minus 2 times 180, divide by the original number 8 there. And when you're putting this into your calculator, make sure you use that fraction button. Make sure you're doing it in a reasonable fashion. I just so happen to be able to do this in my head, but not a big deal. You could do it too if you practiced. All you have to do is really, it's 8 minus 2 is 6. 6 over 8 is 3/4, 3/4. 180 divided by 4 is 45. 45 times 3, 135, whatever, doesn't matter. We're doing this next question. 1, 2, 3, 4, 5, 6. I recommend just counting the sides for both of these. I'm not really doing all that much effort here, just multiplying all those different sides, and the formula is given to you in the question. 360 divided by n. You are trying to figure out the measure of one exterior angle. You're really finding out what this measure is out here, and that measure is going to be the total 360, always 360, divided by the number of sides, and you get 60 degrees. Likewise, on this one over here, same exact concept. 360 divided by 8 is going to be 45 degrees. Bada bing, bada boom. There it is. After that, moving on to question number 11. Get my Razer mouse pad in the background. I got it with my Pokemon one. I just got a new Pokemon one. It's really, really cute, but it's not set up. So I got to actually set it up. Anyways, I'm going to keep on going. We got this 30-25. State if the polygons are similar by setting up a proportion and simplify. Can't see the word simplify because of my face, but that's okay. You are simplifying these. What you're going to be doing is you're really trying to figure out where you have like one fraction. So you're going to make a fraction equals a fraction. That's kind of what a proportion is. Always going to be a fraction equal a fraction. And really, this is going to be like one of the figures, and this is going to be the other figure. So you're kind of going to have to pick maybe the top and the right. So I picked the top and the right, 30 over 25. And then I'm going to pick the top and the right over on the other one. So you got to make sure you're picking the same exact position, and we call those corresponding. So you're picking the corresponding position. Again, I'm doing 30 over 25, 24 over 20. And now you are actually checking to see if this is a true statement or not. The easiest way to do that is to do this on your calculator. All we're going to be doing is doing a nice little division. If you divide this into your calculator using just a regular old decimal, you get 1.2 is equal to 1.2, and that's pretty much it. And that is a true statement. So because the answer is yes, there's my setup equation. Really, that's kind of where that should go. And then my final answer is yes, similar. Over here, same exact concept on this number 12. The only difference is the 8 and the 10 are not going to be the same as this 12 and the 12. So I'm doing like this over this. I'm doing the top over the right equal to the top over the right. However, if you did throw that into your calculator, it would turn out that 1 is equal to 0.8. That is clearly not true. No, not true. So the answer is going to be no, not similar. If you want to just say yes and no on the test, that's okay. I'm not going to make you write out the whole word. Anyways, we're continuing on. The polygons, each pair are similar. Find the scale factor of the larger figure to the smaller figure to the larger figure, sorry. Be sure to simplify. So anytime you're doing one of these problems, your scale factor is always going to be equal to pick a side of the figure, and it's going to be like the big figure, same side, divided by the small figure, same side. So I cannot use this 24 because it doesn't have what's called an analogous side over here. So I can't use this 24. Likewise, I can't use that 8 because it doesn't have that analogous corresponding side over here. I can't use it. So I can only use either one of those, and you just pick one. It doesn't matter. So you have a choice on this problem. I'm going to do either the 24 over the 6, or you could do 32 over 8. In the scale factor, what it's really asking you is what number is it, regardless of what I get the same answer. I get 4, and that is my final answer. The question you're really doing here is trying to figure out, how do I multiply from one figure to the other? If I did 6 times 4, I would get 24, and that's my scale factor concept there. All right, moving on to this next question. We're going on to question number 14. So question number 14 there, state the polygons each pair similar, find the missing side length. So in these questions, my recommendation is actually not to use the scale factor method, although you can. If you want to use the scale factor method, you might be able to figure it out yourself by doing like, hey, how do I go from here to here? Well, I divide by 2, right? So that means to go from here to here, I would also just divide by 2 and get myself 8 as my answer. But the real way to do this question is with that proportion idea that we were just talking about in the previous one. So that proportion idea is going to be, if we just did something like 16 over 12 is equal to this x value here, this x over 6, and then you can do some a little bit of multiplying. So we're going to multiply both sides by 6 there. And we are throwing that into the calculator. When you throw it into your calculator, make sure you're using that fraction button on the calculator. You're just multiplying those two things. It should be easy enough. This number 15, I'm going to actually show all the work for it. Make sure we're really getting that idea, really getting that concept. So what are we going to do? We're going to be doing the x up here. We're going to call that the letter x. And we're going to go x divided by 12. So we did the left over the bottom equals, we got to do the left over the bottom, the 8 divided by 4. And then what are you going to do? You're going to take that 12, move it up there. So x is going to be equal to 8 divided by 4 multiplied by that 12. You throw that into your calculator and you will, in fact, get, what will you get? 24? Yeah, 24. There it is. Continuing to get this show on the road. Really not enough room on the page to do these problems. First of all, this is a plus sign, not a division. Some people in my class were saying the printing wasn't good, and I agree with them. Printing on this one was definitely not the best. But we have 4x plus 1 right there. We're going to start with that. We always want to start with the x, and we are creating an equation. So when you create that equation, you're starting with that 4x plus 1 on the bottom. After you start with that 4x plus 1 on the bottom, you need another number, and you can pick the 35 or the 20, but you got to be careful because it has to have that corresponding side on the other problem. So the 20 cannot be used because there's not a corresponding side over there, so we can't use that. So instead, we're going to use the 35. So 4x plus 1 over 35. So we did the bottom over the top equals the bottom over the top. From there, you really got to actually make sure you are plugging this into your calculator. 15 over 21 times 35. So we're taking that 35, putting it over there. And when you are doing that, we're going to go ahead and I'm going to use my calculator's fraction button. And we're going to get 15 over 21 and then times that 35. It turns out you get 25. By the way, if you wanted to do this in your head, you could. Here's how you could do this in your head if you didn't want to use your calculator. 15 and 21 both divide by 3. So they both divide by 3, and you can kind of reduce that to a 5 over a 7 because they both divide by 3. And 35 divided by 7, well, 35 divided by 7 is 5, and 5 times 5 is 25. Regardless, you could have just done the calculator method instead to get that 25. I don't really care. After that, I think it's nice and easy question. We're doing some basic algebra. Subtract 1 on both sides. Divide both sides by 4. There it is. X is equal to 6. Same exact concept on this next question. Totally out of room on this review. Sorry about that, guys. So it goes. We're going to have the same setup. The x plus 8 divided by the 40. X plus 8 over 40. So we did top over left. So we're going to do top over left here equals 12 over 32. Same exact thing. X plus 8 equal to 12 over 32 times 40. Use your calculator effectively. If you throw it into your calculator, you get 15. And then subtract 8 on both sides, and you will get 7. There we go. Continuing on here. So we have each pair of triangle are similar. So for this one, you have to be a little bit careful because the triangles are not oriented in the same way. What I mean by that is on this figure over here, both these figures were kind of like, you know, the pointies up here, the pointy, those little wider ones on the right. But this one, these are actually twisted and turned upside down. Basically, we're going to start off with that 3x minus 14, just like we've been doing in all these questions where we start off with the variable. But once we started with that, that came from the letters like here. This is the letter T and the letter F. So because it's the letter T and then the letter F, that is the first two letters of this one. So the 3x minus 14 is that first two letters. So on the other side of the equation, when you're doing this one, I mean, obviously you're going to have 24 in the bottom because it's going to be like this over this. But the 70 is actually going to be what is the correct answer here, because the TS on the other one, the first two letters, TS is going to go over that 70. So again, the first two letters TF, second two letters TF, first two letters TS, there it is, 70 over 60. And you could verify this, that TG is the first and the third, and that 60 is RT, which is also the first and the third on there. From there, it's the same exact stuff you've been doing all day. 70 over 60 times 24. Use your calculator effectively. 3x minus 14. On this one, I think you really could do in your head, by the way, because the zeros cancel out. You get 7 over 6. 24 divided by 6 is 4. 7 times 4 is 28. You are absolutely capable if you put your mind to it. Added 14 to both sides. Divide both sides by 3. There it is for that one. The x equals 14. Same exact idea in this one. There's not really too much to say. That longer side, 7x minus 1 over 15 is equal to 45 over 25. 7x minus 1 is equal to 45 over 25 times 15. 7x minus 1 equals, and then, yeah, you got to do a little bit of math again. What's that going to be? It's going to be 3 over 5, so 3 times 9, 27. Add 1 to both sides, you get 28, and x is in fact equal to 4. They weren't even like answer boxes on that one. Gotta admit, this is not well designed. My bad for not telling the team to redo it. So it goes. All right, on this one, this is going to be one of the easiest questions on the test because of the way it was written. It was written such that you can get the answers really, really well, really fast. Because you only have three options: side, 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 angle, side, and angle, side, angle. Angle, side, angle's not even there. Side, 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 angle, side, and angle, angle. I'm thinking about congruency. And in the problem, you'll notice that this one doesn't have any angles written down. Like you see, there's only numbers. There's no angles written in. And this one has like 2 angles. So this one that has no angles, guess what? It's side, side, side. This one over here that has no sides and has only angles marked up, guess what? It's angle, angle. Wow. And the last one down here, you're going to see it right away in a second here. It's going to end up being a side, angle, side, because you have a side, an angle, then a side. However, on this guy, what we are having to do is making sure that we are lining them up correctly. It already tells you that they're similar, so you don't have to actually check any of these proportions. But what you do need to do is make sure you write that triangle symbol. And after you've written that triangle symbol, you got to go in that correct order. You started off at L. L is in between, looks like the smallest side and the largest side. So we need to go find the smallest and the largest side here. That's these two. So then we're going to start off with the letter S. After we started off with that letter S, it looks like we started off with L here and we went to M. So we went across the biggest side. So you start at S, you go across the biggest side, and that's going to be down here to the letter T. So STU. On QRS here, you did the double angle, the triple angle, and the blank, which means that you need to do the double angle, the triple angle, then the blank. So QGF. That's a Q, a G, and an F. Sorry, guys. All right, continuing here, we got triangle LKJ. We have an L, a K, and then a J. So our LKJ there, we're starting off at that letter E. That's because you're starting off with the double angle there. So you have triangle with that letter E. And then it's LK, goes across the smaller number. So across the smaller number will be an F, and then a G. We only have one more page left. Heck yeah, guys. So that one last page is going to be our PSAT questions. These are stolen straight from that PSAT website. When I mean stolen with permission, they said we can use them. So that's what we're doing. What is the measure of angle Z? Guys, this is a triangle. Triangles add to 180, 180, minus 24, minus 98. Shouldn't be too much effort. What that's going to be, 180 minus 100 is 80. And then 22 more is, what is that going to be, 58? Yeah. Done, 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 done. Moving on to the next question. This is really funny. Like, how can a measure in a triangle be 212 and the other one's like 98? Like, that'd be over 202. These are some really bad answers from Mr. SAT writers. They need to step up their game. All right, this next one, these two things are similar where P corresponds to S, or in other words, this guy here is the same as this guy. These two angles are the same, which means that these two angles are the same as well. And if Q is 18, so this is 18, meaning that this guy is also 18, what is the measure of angle S? Well, angle S is down here, meaning that we need the other angle in the triangle. So 90 minus 18 is in fact 72. We're done with this thing. Have a wonderful rest of your day, guys.